Hello and welcome to Embedded. I am Alicia White alongside Christopher White. I've talked some here about the online compiler from Mbed. We're going to learn more about that, but do you know that there's a simulator for it? Jan Jongboom from ARM is here to tell us more.
Hi, Jan. Thanks for being with us today.
Hey, hi.
Could you tell us a little bit about yourself?
Yeah, my name is Jan Jongboom. I am a developer evangelist at ARM. And part of that is developing all kinds of new and interesting features that I think our community loves. And indeed, I've been working on a simulator which allows you to run basically Cortex-M, emulate Cortex-M devices running ARM Mbed straight in your browser.
Cool. So I am going to start lightning round where we ask you short questions and we want you to have short answers. And if we're all behaving yourself.
Behaving yourself, ourselves.
Ourselves. It's all us that this goes badly with. Then it will go very quickly. Are you ready?
Yep.
Favorite processor?
Cortex-M3.
That's a core. All right, we won't push it.
Oh, sorry.
I know you probably can't be. You probably can't have favorites. Do you think we are in a simulated reality, and how would we know?
I think there's definitely a chance of that. How would we know? Try to find the glitch.
Embedded development or web development?
Very tough question. Traditionally web, but I've started to like embedded a lot lately.
IoT, more internet or more things?
More things.
Favorite Internet of Things protocol?
Do you mean like BLE and Wi-Fi?
Yeah.
Okay.
LoRa WAN.
All right.
What is the best board for someone wanting to move away from the, I guess I have to say Arduino. I can't hint around Arduino.
Tough question. I mean, I started out with the Nordic Semiconductors NRF51 DK, and that was an absolutely great choice, but obviously I can't pick sides.
Yeah, BLE is a nice place to start because it's got so much functionality.
Absolutely, and it works as like a personal area network, so you can easily get something on your phone running, and it's really, really easy to demonstrate.
What's a tip that you think everyone should know?
Programming is not hard. It's just logical thinking and writing it down.
All right.
So now for longer answers. The first one basically could be the rest of the show if we do this wrong. What is Mbed?
Mbed is ARM's Internet of Things device platform. So it spans a variety of products from an operating system for microcontrollers to device management cloud and everything in between.
So there is the compiler aspect to it. That's all online. Why? I mean, there are lots of existing compilers out there. Why have an online one?
So, I mean, the first thing is to stress that it's not just the online compiler. We integrate with IR and Kyle NDK and all the other IDEs, and we have some local tooling as well with Mbed CLI. Historically, the online compiler started because, in late 2009, I think a lot of listeners still remember that, all your tools for building embedded devices were paid for and only ran on Windows, and we wanted to have something that people can get started really quickly. And what's easier than opening your browser and going to a web page and typing in some code and then hitting compile?
And that's where it kind of started for me. That was where I came into Mbed, is that I got a board that said, go here and there's a compiler, and then the compiler didn't have an IDE. I didn't need a JTAG unit for this board. How do you do that?
Yeah. So, I mean, first of all, I really recognize that. I mean, for me, I was writing code for an Atmel microcontroller with AVR Studio or Atmel Studio. And it was a relatively painstaking process. And then someone handed me the Nordic Semiconductors NRF51 DK, which was an Mbed-enabled board at a hackathon. And I was like, this is amazing. This is how I want to write my code, not in a Windows environment with a proprietary IDE. But yeah, coming back to your question, how do you don't need an external JTAG. So we have a project called DAPLink. And DAPLink is some software that runs on a secondary MCU on almost every Mbed developer board. And that contains, next to the debug interface on the Cortex-M processor, So we fake a file system. We fake that we're a USB drive, and then whenever you drag your firmware onto the fake USB drive, we use the debug access protocol to flash the actual target MCU, which I think is a really clever trick because it doesn't require you to have any drivers or anything on your computer.
But that means I can't step through my code, right?
Yeah, through that link, you can also step through your codes. So we have the PyOCD project, or the OpenOCD project on some boards from ST, and those will actually give you full debugging capabilities. So you don't even need the JTAG to step through your code. You just use GDB or Visual Studio Code or Kyle MDK or anything like that to debug your code.
Do hardware developers pay any price for having that extra MCU? Is there a power kind of cost for having that on the board, or is it something that you drop when you go to production?
It's something you drop when you go to production. So typically you add a normal a DAP interface, like the 10 pins or 8 pins, and then you program through normal JTAG if you go to production.
Okay, cool.
So these are intermediate boards. They're prototyping boards.
Yeah, absolutely. But absolutely prototyping. The development boards. So incomparable to what you would put on an actual product. But the MCUs that are on the board, those are the same ones there.
You've mentioned the Nordic NRF51, and I know they have a 52. Actually, Nordic supports the Mbed platform quite a lot. What are their chip vendors?
That's a lot.
Is this everybody who makes an ARM Cortex?
Not everyone, but a very large chunk. ST uses it for a lot of their boards. We have NXP boards, Renesas. Yeah, it's virtually, I wouldn't say everyone. We have 140 different boards from, I think, 60 different partners.
So you should be able to find something that matches your requirements.
Yeah.
And if I make a board, how hard is it to get my board on there?
So we have an Mbed enabled program. If you pick an MCU from a vendor that already supports Mbed, it's absolutely trivial. If not, then you need to port the hardware abstraction layer that we have. But because we're building on top of CMSIS RTOS, which chances are 98% that your MCU already supports that, porting is relatively straightforward.
If I'm already comfortable with my desktop compiler, my IAR or my Kyle or whatever, why would I even try Mbed?
So Mbed is a lot more than just a compiler. I think it's a very sane set of middleware that every IoT developer needs. Every IoT developer needs a network stack, IPv4, IPv6. Every IoT developer needs TLS libraries. You probably need a bootloader if you want to add updates. You need an update client in that case. File system drivers. We have with both FAT file system and our own very resilient file system specifically made for embedded. And if you choose Mbed, you don't just get the community or the online tools. You also get all this middleware that is well tested, maintained by ARM, and maintained by our engineers to actually ramp up our IoT product a lot more quicker.
So if I make a board, if I make a product and I use an Mbed board for development, and I use your compiler and your RTOS and networking stack, and then I make my own board and I have a JTAG, what is my path here? What is the transition path to more traditional tools?
So you can just start developing in your IDE while you're already using our development boards. After that, you take actually just a normal path of productizing something that you hooked up on a breadboard. So you design a new PCB with the same MCU on it, or maybe a different family, a different variant in the same family. You hook up everything, and then the same binary that we created, even in the online compiler, or the binary you created in IR, you can just flash on the boards through JTAG. There's nothing special in the binary.
Is the RTOS and everything, can I download it and compile it with IAR? Is it binary? What is the licensing?
Yeah. So almost everything that we have is licensed under the Apache 2 license, so very, very permissive license. And it compiles with GC6, ARMCC5 and ARMCC6 and IR. I think IR8, latest release. Some parts, and it's mostly like networking drivers, etc., that come from partners, are available under a permissive binary license. So not an Apache license, but you can just embed it in your product without having to pay anyone.
So one small elephant in the room is that we haven't mentioned that, and I think I'm right, is that most of these frameworks are written in C++, and your code would be in C++ as well.
Doesn't have to be.
No, so we have the hardware abstraction layer is basically in two flavors. One is C. That's what the vendors need to port.
Okay.
So we have a C hell for the vendors, and then a C++ hell for developers. If you really want, you can use the C variants. In general, I think the C++ API, especially for stuff where you do RTOS things or using network stacks, is a lot more friendly. But you have some freedom in that.
Do you find you get any pushback from having C++ so prominent in an embedded? I know a lot of developers who are not so big fans of C++ and embedded. I'm not one of them, but has that been a challenge?
Less than I anticipated. I think the main concern with people is that they're afraid that if they start using C++ on their thing, that it actually will blow up in code size.
Right.
I've written, I think, 5 or 6 blog posts on reducing the code size for Mbed projects, and after you link them to that, they often start to realize that that's not that big of a problem. But yeah, not that much pushback actually.
And there's a lot of existing code, not just developed by the folks at Mbed, but there's
big community,
a huge community,
yep.
And all the licenses are very permissive.
Yeah, I think so the default license, if you publish anything on Mbed, is Apache 2, but you can license it into something else. But yeah, I think our online community at os@mbed.com is amazing and has been an absolute catalyst behind the success of Mbed. I think we have 20,000 different libraries published there. Literally every component that you buy in a random, you have in Tokyo, you have the electronic stores with all these random components. Like the chance is 98% that you pick a random component and someone somewhere has already written an Mbed library for it, which I think is pretty amazing.
It is pretty amazing, especially when I go to try to make something for a new flash chip or an ADC I've never used. And I can go to Mbed and there'll be a library there with Apache licensing, and I don't have to make my own header file. I just have to tweak it to use my I2C or whatever.
Yeah, it's brilliant.
Why did you go the C++ route? Was it partially influenced by Arduino?
Good. I was not there at that point, so I can't comment on that.
I like that about it. I do like that the Mbed Mbed compiler and environment feels like a stepping stone from Arduino. Do other people say that, or do you just not want to talk about Arduino at all?
So actually, ARM is an Arduino partner as well. We have, like, my boss's boss is on the board of Arduino. A good friend of mine is in the board, is CIO of Arduino. I have a really good working relationship with them. I think what we try to do a little bit more. So Arduino really focuses on developer experience there, and we want to look at all the aspects that you're looking at if you want to build a secure IoT product, and then offer a solution everywhere on that route. So yeah, I think Mbed and Arduino are actually pretty complementary. Arduino has made it really easy to get started building IoT products. I started, my first project was an Arduino on Embedded. They both have their place. We try to do a little bit more.
Arduino has a huge library. You have a huge library. They don't exactly overlap. So they overlap in spots, but not entirely. Yeah.
So I think one of the maybe not one of the issues, but what Arduino is missing, without trying to sound negative, is Arduino doesn't have an RTOS. So also a lot of like the RTOS primitives, locking mutexes, are not implemented in libraries. At least all the libraries that we put out are thread safe and can be used in an RTOS environment. So I've contemplated about the idea of having some sort of Arduino compatibility layer for Mbed, or the other way around. So having an ecosystem where you can use both. But there's just they're both catering to different publics, so they have to be a little bit different.
And you mentioned the security part. That's always something that's a little daunting. Like, I know I need good security, but I also know that I shouldn't be developing myself.
Yeah. So, I completely agree. I think security is fundamental to any Internet of Things product, and we've seen how easy it is to get all your devices hacked if you try to roll something yourself. I think ARM is in a position to both do the research and invest the money in building a common set of middleware items, from a TLS library to integration with TrustZone or with your memory protection unit, to having a secure firmware update service on the device. That I think that it would be better if we would all channel our efforts and standardize on whatever we're building. So that's why ARM is investing a lot of money in these security features.
Do you ever worry that your code is being read? I mean, it's open. Do you think about, as you write the code, do you think about who's going to read it and how legible it needs to be and all of these, oh my God, it's open source issues? Or is that just me?
Before I joined ARM, I worked at a large telco, and they donated my time to the Mozilla Foundation. So I'm very aware that all my code is out in the open, because all the code we wrote for Mozilla was out in the open, that it has to be reviewed by 2 or 3 people. And for me, it's not really a difference. I like it, actually. I think the more people see the code, the easier it's going to be to spot any issues with it.
I like being able to read the code because it gives me good ideas for my own code. A lot of the Mbed things are written in good C++, not overly complicated, usually aware of memory situations. And so it is nice to see embedded code that other people write.
Yeah, I completely agree. I moved from being a web developer to being an embedded developer, I think 3 or 4 years ago, and being able to tap into this vast ecosystem of code that I know works and actually powers millions of devices. For me, that's I can totally see where you're coming from.
One of the difficulties with having a class, with teaching a class about embedded systems, especially one that's online or distributed, is not knowing if everyone can get the same hardware, and if they can get it working on their computer.
Yeah.
So I was very excited to see you have a simulator. Could you tell us about it?
So am I. Yeah. One of the things that I kind of hate about embedded development is that the feedback loop is very long. You need to compile your code, you compile your application, which takes a bit. You need to flash your application, and then you need to get your application again in the state that you're testing, or that you're basically in the state that you're testing. And so when I saw the microbit project, which is being written by a couple of my, or worked on by a couple of my colleagues and a whole bunch of other companies, they have an online editor. It's actually a block-based editor, but they also have the simulator directly on the screen on the right, and that is such a powerful tool. I flew to Trondheim for a Maker Fair at Trondheim a year and a half ago, and I was teaching kids how to do microbit in Norwegian, which I don't speak, and just the whole mere idea that whatever they just click together, they can test directly in the same browser window before even flashing on the device, which is going to take, even in an optimistic case, 20, 30 seconds. That is so cool. And from the moment that I saw that, I realized I want that, but then a bit more open and a bit less focused on just a single development board. So that's why I started the simulator project.
And what stage is it in right now?
It is. I'm still a bit wondering where it fits in our developer flow. So right now the simulator just sits on a website. On the left you have an editor, on the right you have the simulator. But I mean, that's not a product, or it doesn't integrate with anything. So I'm looking at, I think it would be really cool if we could test our cloud services directly through it. So you could say, spin me up an instance, and then it will just run a simulator, and you see actually a board appear in our device management cloud. Or if you go to one of our documentation pages and you see some example code, you can just press the run button and it will run in the simulator. So it's pretty stable. It works quite well. It's definitely, but I don't want it. I want it integrated in a different way than it currently is, as a completely standalone product. I want it integrated in our compilers, in our examples, etc. So that's what we're going to focus on for next year.
So is it a simulator or an emulator? Is it actually doing the ARM processing, or is it? So
the cutoff point. So if you look at an Mbed board, you have your application, then our C++ HAL, then the C HAL, which the vendors implement, and then the board, and you need to toggle registers to make LEDs blink. So I implemented the simulator as a set on the C HAL level. Okay. So according to Mbed OS, it's just another target, and that the target then underneath draws a board on an HTML page instead of toggling some registers. That's where it is.
Cool.
But the nice thing there is that I can reuse almost everything that we built already in Mbed.
Okay, let me describe what happens when I load the simulator, because Jan was very focused on all the things he wants to have happen, but you should see, at least audioly, what I'm seeing. So over on the left side, there's include embed H, digital out, LED, LED1. I assume that's defined somewhere. Usually in embed.h, it goes down and it finds the board you're on. Yeah. There's the main while one, LED equals not LED. That blinks it. That is all you need to do to blink the LED. And that would be true on any Mbed supported board.
Yeah, correct.
And then there's print, LED is now LED.read. And then it waits 500 milliseconds, and that's all. So that's the code. It's short. This is just Blinky. And there are a couple other demos, but let's continue with Blinky. On my right-hand half of the screen, there's a little blue board that looks kind of like the NXP Espressos got cut in half. It's not very big, but there's a button and a virtual button, but it's clearly a button. And there are some labeled pins, fake pins, SPI, I2C. And then there's an LED that is blinking and a serial output that says blink LED is now 1, blink LED is now 0. And it goes on and on and on. So if I change something, if I change the wait milliseconds to 1,000 instead of 500, it would blink slower, and I can add components that will have more LEDs or different places. And then there are a whole bunch of different demos. I mean, this is Blinky. This is just Hello World. There's one about interrupts that has to do with using that button, that fake button there. PWM out, so we could make the LED go soft. You can add a fake simulated LCD display, a touch screen, a temperature humidity sensor. And then there are the networking ones, TCP socket, HTTP, HTTPS, CoAP. And that means you can simulate all this stuff with this website and have it go out and do all the things you want to try. And there's all this, and none of these are hideously long programs. They're all things you can read and try. I mean, the HTTPS demo has a certificate in it. So it's, there's some non-cuteness here, but overall it's like a page of code. And I am happy about that. It lets me learn about these things easily. So, what did I forget?
Yeah. No, that's pretty spot on. I mean, for me, it's like the things that I wanted to make sure of, that one, the code that you write on the left-hand side in the editor needs to be 100% Mbed valid. If you run it on a board, it should run exactly the same. And I also didn't want to make it like dumbed down. So that's why you see in the HTTPS example, you actually have to specify the certificates that you trust. And that's because we're using the Mbed networking libraries directly. So it's not just faking. It does an XML HTTP request to the HTTPS service that you do. It actually opens a socket and then does a DNS request, and then actually, does a TLS handshake, and all in the browser. So it's not a dumbed down version. And I think that's what makes it really powerful, because I was working on I'm maintaining the HTTP library for Mbed, and I was on a plane from Italy back to the UK, and I just wanted to hack on the HTTP library, but I had to whip out the development board and have a local server running. It's all pretty terrible. So I wrote my new feature, which was about content streaming over HTTP in the simulator, and I tested it 2 hours later when my plane landed. I tested it on a real development board, and it just worked exactly like it did in the simulator. And I think that is super cool.
Well, I think your intuition is right too about the need for these kinds of things, because embedded development is very slow, and putting real hardware in things always probably halves or quarters the speed we can actually go.
Yeah, I think so. We're kind of in a renaissance for embedded development. 2009 or even 2012, when I shipped my first embedded product, still a lot of stuff was on Windows. You needed external JTAGs. The development cycle was so incredibly slow. And now, first of all, almost all the tools are cross-platform. So that's already a great step up. And I think we're gonna now see an actual renaissance in development tools and how you develop things. And I'm pretty excited about that.
But this simulated board, is it real? I mean, you say I could load this code to a physical board and I would expect it to work the same.
Yeah.
But what is this board that I'm seeing as it blinks its light at me?
So the hardware abstraction layer, so all the pin names, they're derived from the LPC 1768 development board, which is the original Mbed board. But if you change the pins to whatever your development board has, then all the examples, including all the peripheral ones. So I've noted the name of the peripheral in the simulator. So if you get the same peripheral, hook it up to the same pins as the simulator tells you, it will run exactly the same on any Mbed board.
That's very cool. What if I wanted to actually support my board in the simulator?
I think for now, I don't want to go really on that route, because I don't want to have any board-specific code in there. So the board looks like an NXP board, but it's not an NXP board. And probably if we're going to integrate this into a product, we're going to make it look less like a real board even. So I want this to be a generic target rather than simulating a specific board for now.
Is the simulator open source too?
Absolutely, also Apache 2 Live.
Okay, so if somebody really was ambitious, they could put their own board in there.
Yeah, absolutely. And I would love to see something like that. Maybe where I would like to have some support, if people are hearing this, if you have some peripherals, maybe on the board, or peripherals that you want to have, write a little abstraction layer for it. You can just write it in a little bit of C, and then most of it is just JavaScript and HTML. And hooking up an extra component is pretty trivial. There's plenty of examples already in there. So I would love to get some support with that.
Yeah, I think it is less about the boards, because given a Cortex M, you have a lot of similarities between boards, but if you are doing a specific memory device or peripheral, I2C or SPI or whatever, that's where things start to get complicated.
Yeah, absolutely.
What about for specific boards? What about DMA and all of these other tweaky features, sleep? And do you deal with those, or do you just leave them in the hardware abstraction layer?
Currently, we just leave them in the hardware abstraction layer. One of the things regarding sleep, one of the things we're adding now to development boards is the ability to track energy usage of all your peripherals, etc., and then graph that out. So it's currently still in the planning phase, but that's hopefully coming to Mbed development boards very quickly. Something like that would be super cool to simulate in the simulator, because you kind of know what peripherals are being used. When you go properly go to sleep, and testing stuff like that, making sure that your sleep cycles are correct. That would be something that would be great in a simulator and easy to graph out.
And you said this is a project that is gaining traction over the next year. Is that right? Do you have deadlines, or is this sort of something you do as you can?
So we don't really have any deadlines. I mean, it's done when it's done.
Which means it's never done.
Well, so yeah, I mean, I have some ambitious plans. They're working, but they're not integrated in our product yet. So for me, it's only done when we actually integrate this in some of our getting started flows. On a technical level, the stuff that I need for that is I've done. It's not open source yet, but it will be. And now it's just working with the product teams to actually integrate it in our flows. I'm pretty confident we're going to be able to do that relatively quickly.
And this is available off of labsembed.com, labs.mbed.com. And when I went there were some other things. What is microtensor?
Microtensor. Yeah, microtensor is I get really excited about it. So microtensor is a deep learning AI inference model that runs on a microcontroller. That are a lot of hard words in a row, but what it means is that you can take a TensorFlow trained model, Google's deep learning tooling. You can train it somewhere on a cluster of GPUs, and then you can push the pre-trained model to a microcontroller and then do the classification on there. And that's awesome because you can do proper machine learning on a microcontroller and push real intelligence to the edge. And because it's the same model that you can also run on TensorFlow, you can actually dynamically shift workloads from the cloud to the edge or the other way around, depending on network conditions or what type of connectivity your device has. So microtensor is super awesome.
That's crazy. I always think of machine learning as requiring a GPU or something like that.
Yep.
But that the idea of doing at least small classification on a microcontroller opens up a whole bunch of applications. What do you have some examples of what you kind of foresee that being used for? One
of the demos that we have is just a simple the handwritten digit recognition. There's like a big training set available. It's like the 101 in machine learning.
The minced set.
Yeah, correct. So we've implemented that. That runs with it under 256K of RAM, which I think is already pretty cool. And now we're going to build a bit like larger and more interesting models. So one of the things that I could be thinking about is stuff like computer vision, especially for constrained devices or devices that have a constrained network connection. Ones that are connected over low power wide area networks where your data rate is in bits per second rather than megabytes. You cannot send out images to do classification somewhere on a cluster of GPUs. You want to do that on the edge. And I think that microtensor is going to give us that opportunity.
And this is the inference framework. This is running the thing that you trained on the GPU.
Yeah, correct. So
you still need that big AWS or GPU system in order to train your neural network. But this is running that neural network and having it be the same code, which is really important because I know a lot of times implementing somebody else's machine learning system, a little changes can change things, like how the FFT library was implemented. If that makes a difference, I've always thought that means you're not trained right, but sometimes it does make a difference. So this lets it be directish, more direct.
Yeah, and I think the compatibility with TensorFlow is really important because a lot of the innovation right now in machine learning space uses TensorFlow. Just last week, a friend of mine released Propel, which is it's basically machine learning for JavaScript. So it's written by two guys that used to work on Node.js, and now they have a set of libraries where you, as a JavaScript developer, can start doing machine learning, and they handle all the hard parts on it. And then after that, you got a trained TensorFlow model. You compile it with the microtensor tools, and now you can run it on your microcontroller, which is it's terrific. Very happy.
I've either got to retire or go back to school. It's very exciting, but it is kind of, this is all very new and I mean, you could do embedded the same way for the last 20 years or 30
Well,
years.
but the thing is,
and now
That's not true.
Well, I mean, most of the concepts are the same. Machine learning is definitely a completely new way of thinking.
Yeah, but I think that Internet of Things or embedded development is going to be crucial for the adoption of machine learning, because for machine learning you need fast sets of data.
Yeah.
And the only way to get all these fast sets of data is using cheap microcontrollers. So I think we are in an excellent spot.
And whatever is taking the data in order to create these sets then has the ability to act on them. And so that is where the inference comes from. That is where you start having to run this stuff, make some decisions.
Yep.
It's not just data collection.
Yeah, correct. So we're moving from just dumb data devices to now we can actually do the classification there. And I think that's cool. I mean, I am teaching, I taught last year at a summer school in Africa, and I'm returning this year. So we're going to be in Kenya, and it's called Data Science Africa. And in there, we're getting students, so mostly mathematics PhDs and mathematics master students who know how to do machine learning, but they don't know enough to actually build IoT devices, to actually do the data collection and then maybe data collection on the edge. So we're just going to go over there for 8 days and run workshops with the students and actually transform them not just mathematician data scientists, but also into IoT developers. So I think the fields are coming together.
You also have a JavaScript on Mbed, which, I'm not really sure about that, but I'm sure somebody is jumping up and down in excitement on that. Could you say a bit about that?
I think it's been called an abomination to every DT to run JavaScript on a microcontroller.
I'm contractually prohibited from commenting on that.
But I think it's in the same ballpark as the simulator. It's a way of making it easier and faster to test out stuff on micros. Things that I can't do in C, but what I'm really missing from my days as a web developer is to quickly hack something together on the web console in the browser and see if it works. So one of the first projects I did with the JavaScript runtime on Mbed is to make a redevelop print loop that runs over serial. So you connect over serial to the development board, and you can just start writing some JavaScript, and it will actually change stuff on the development board or start toying with the peripherals. And that's a really cool way of demonstrating how this Internet of Thing or embedded thing works to people who've never done that. Are we going to see it in production systems? Maybe. But I think it's a really interesting research project. And the first simulator we built was actually for the JavaScript runtime. So, you always build on top of what you've been doing before.
And all of these are free.
Yeah, Apache 2 licensed, all of them.
But ARM also sells the Kyle compiler.
Yeah, correct. Yeah, I mean, ARM has our main bread and butter is selling architecture licenses or selling chipset designs.
That's the Cortex M3 or the Cortex M0 Plus. The actual core comes from ARM and then is put into a chip developed by ST or Nordic or any of the other names we've mentioned. Yeah, so we're fabless, but that's pretty much correct. Plus of course all the processors that go into mobile phones. I think 99% of all mobile phones use an ARM core inside. And then on top of that, there's some other things like some money is being made by using the Kyle NDK and the ARM compiler. We don't tie all the projects that we do in with that. You can also compile it with GCC, although often your code size is a bit higher, your memory size is a bit higher. So sometimes it still pays off to actually buy a compiler. But we're also in the software business. So Mbed is a vehicle of selling more chips. But we also have some services around Mbed. So we have Mbed Cloud, the device management platform, and that's a paid subscription that works really well with the rest of our tools in our ecosystem. But you're not forced to use it. If you just want to use Mbed OS or our labs projects, completely free and completely open source. So
the cloud part would be like they would do your device management and data storage and that kind of thing for you. Is that what that does?
Not even data storage, so just device management.
Okay. Just device management.
It's all the stuff that you're going to run into if you start shipping 100,000 devices. Like all of a sudden you need integration with the factory tooling in the factory, and you need to have device identities, and these device identities can't be burned into the device because maybe you don't even know who your customer is, or the device may be resold and you need to re-provision them with new keys, and you need to do firmware updates over them, and it all needs to be in a really secure manner, both on the device, integrating with your silicon features, and in the cloud. And that's Mbed Cloud.
And then can I also send data through Mbed Cloud to get to wherever I needed it? I mean, because the device management is very complicated, but then I also want to be able to talk to it for whatever reason I had to build this thing.
Yeah, so I mean, there's two ways of doing it. We don't store your data, so we can use it as like a data plane, and then we proxy your data to wherever you want to with an API to get it out. Or what I think is also a very viable option is say, well, I use Mbed Cloud for my device management, and then I just open a socket directly to whatever other cloud provider to actually dump my data straight into the database.
Okay. So I could use AWS and have it talk to the Mbed Cloud in order to get all the data from my sensors. Yeah,
absolutely.
Cool. Let's see. Changing topics rapidly and without warning. How was Embedded World?
I think trade shows in general, the first day is really exciting. You see all the products and you have a lot of energy and you see all these people. And then the second day, it starts going a bit slower. And then on the third day, you just want to go home.
It's one of the larger embedded conferences. Is that right?
Yeah, correct. I think one of the I mean, I spoke there. I think it's really cool. One of the great things about having a conference that big and so niche, basically, is that you have all these like super specialized tracks, and then there's multiple people talking about it. So there was a energy harvesting track, like a half day, just people talking about energy harvesting. That is insane. That is pretty cool. So I spoke at the LP1 track about firmware updates over low power wide area networks, which is one of my other pet projects. And yeah, it's pretty cool, pretty inspiring. The downside of a conference track like that is that because all of these things are so niche, they start spreading it out. So they have like 10 separate tracks at the same time running. So you maybe have 60 people in your audience, which is not that much.
It's hard to balance where you put your time, especially with in-person things like that, because you can get really detailed, but then you do have a smaller audience. So that makes sense.
Yeah. It depends also. Like Embedded World is important, not just because of the conference and not just because of the trade show, but because everyone is there. So it's great. Everyone that you ever want to speak to, every company you want to speak to is going to be there. So I think it's like, for me, it was pretty useful to be there. But yeah, conference wise, I was speaking at the Things conference in Amsterdam, just focused on LoRa WAN, a bit the same talk or a very similar talk, and then we had 650 people in the audience. So even very niche topics can all of a sudden draw an amazing audience.
Do you have any place else you are looking forward to speaking in the near future?
I am flying to South by Southwest on Wednesday,
wow.
the large interactive festival. So if you're going to be there, I'm not sure when this is going to be published, but on 10 March, I'm holding a workshop as part of the official South by Southwest interactive program. So it's going to be 2 hours of exploring a long-range Internet of Things. So we're going to build some LoRa network using Mbed, of course. And then on the 14th of March, we have a meetup. No badge required in the ARM offices. You can search for IoT Deep Dive Austin on Meetup, and you'll find it. And we're gonna talk about long range IoT. We're gonna talk about LoRa, do some demos, and then eat some pizza and grab some beer. So if you're around in Austin, come by.
What draws you to LoRa?
It's in general, it enables me to do things that I could never do before. Like it's always this balance between either range and power consumption. So I love BLE because it is very low power consumption and it just magically works. But the downside is it only works, 30 meters afar. Or I can do cellular, which is great because the range is fantastic and it works everywhere. But then I drain my battery within a week. And I was really looking for something that gave me like BLE type of power consumption, but then with a really long range. And I found that in LoRA. That's 3.5 years ago. Yeah, it's just brilliant. Like the first time we did a transmission, we put up a LoRA gateway on top of the building where I worked. And we could see on the other side of the Oslo fjord, because 8 kilometers away, we could actually reach the gateway with our little small device, knowing that it was still going to run for a year on a pack of AA batteries. That was really cool.
Wow. Okay, we have to do a show on LoRA at some point.
Ampower did one recently. It is really cool.
Yeah.
I guess I'll link in the Ampower show too.
Yeah.
So, I mean, there's more technologies in the same space. You have Sigfox, who's like father to technology, and the telcos are catching up on it by doing narrowband IoT. So it's in general just a really good place to be in connectivity-wise at the moment. Everyone is waking up onto this and realizing that IoT connectivity, machine-to-machine connectivity, should be done without a SIM card, and it should have long range and low power. So I'm excited about that.
It should definitely break all the laws of physics.
Yeah, if we could do that, then we could also have really high data rates. That would be even more amazing, but not yet.
Well, Jan, we've kept you for long enough. It was great to talk to you. Do you have any thoughts you'd like to leave us with?
I think the embedded space at the moment is so energetic and so full of fun. We're seeing, a renaissance in development tools. We see a lot of the things that desktop developers were used to, simulating devices, just stepping through code very easily, actually making it back to embedded. We see new networking technologies that all of a sudden give us things that we could never dream about popping up. So I think embedded is a fantastic place to be in. And I can't wait to see what the future brings.
I completely agree. It's exciting time to live. Our guest has been Jongboom, developer evangelist at ARM. You can check out this simulator and many of the other things we talked about on mbed.org or labs.mbed.org. Jan's website...
labs.mbed.com, sorry.
.com, sorry. The link will be in the show notes. Don't listen to me now. I never say anything right. Jan's website is jongboom.com, where you can see some of his talks and his writing. Check those out. It's pretty cool. And again, link will be on the website in the show notes. Thank you for being with us, Jan.
Thank you.
Thank you to Christopher for producing and co-hosting. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit that contact link on Embedded FM. And now a quote to leave you with from Carl Sagan. Somewhere, something incredible is waiting to be known. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.